Hello everyone, welcome to this video, and in this video I'm going to discuss how to do multiple linear regression using Microsoft Excel. Let's get in. So, so when we're talking about multiple regressions, they are a consideration of two or more independent variables. So this two or more independent variables, you would like to check if it is a predictor or not of our dependent variable. And then we can make a model or an equation. The model of the equation is like a very long linear equation, which is there a lot of b. So it is now the dependent variable, which is y hat, is equal to b sub 0, which is our intercept, and then b sub 1 x sub 1 plus b sub 2 x sub 2 plus until to b sub p or x sub p, or how many predictors you want to try minus the estimated error. So however, we're not going to do this manually. So we're going to use now Microsoft Excel. Let's look at Microsoft Excel about let's look how to use this in Microsoft Excel. Hi, so this is now our data set for our multiple regression. So let's define first our variable. So income, assuming that there is a survey, but I created this data, so don't worry. So there will be a scale. So for example, the income turns out to be your dependent variable. And then on my first video, I use attitude. Now I added one more set of variable, which is educational attainment. So it was coded. So it's like this one, it was coded as well. So let's see if the attitude and educational attainment would be a predictor for our income. So we will use now the still the same tool in Excel, which is data analysis, which is regression. And let's see this one. So clicking now regression. So assuming the default there is that there's no data there. So you better erase everything so that you would see things. So first thing is that I'm gonna go with our dependent variable, which is the income. And then let's go on our predictors or possible predictors like the attitude and educational attainment. So I click now the labels, and then I'll click now the output range. The output range is still the same. It's E, or but the default there would be on the new worksheet. And then there are a lot of things here that you could look at. However, let's go on primarily the result with this one. Okay. So when I click now OK, so let me just adjust the viewing experience with this one. So let me just put it on a two decimal places with our data so that it's much clearer for us to look at the data. So I have here the data. So let me just highlight once again the important details here, such as the R squared, the adjusted R squared, and then we have here the intercept, or what we call the coefficients that we need for our model, and then the significant F. Oh, that's a very good um, detail. And then the p-value and the t-stat. Okay, let's see now. So when we look at now, let's go back to our model. So our model will lead us to our y as our independent variable, and then b sub 0 is our constant, or we could see here it is our intercept. So I could say that it is 784.72. And then our b sub 1 is our attitude, which is 3013.89. And then our b sub 2, which is the numerical coefficient or the slope for educational attainment, is 1645.83. Mhm. So let me just type that. So let's have now our model. So our model could be written in this sense that y is equal to 784.72 plus 3013.89 x sub 1, x1, put it x1, plus 1645.83 x2. So those are the things that our model would look at. So this is our model. So whatever the input value of x would have a result of this. However, let's go on our coefficient of determination. It's 0.90. However, that's a very high level. However, if you are using a multiple This is r squared, so this is our coefficient of determination, and then our adjusted r squared is the thing that we're going to. Some says that this is the thing that we're using if we are using multiple variable or multiple independent variables. So we're using the adjusted r squared, so that would be 0.86, and it's still high. And they say here on the significance, it's 0.00. It's a p-value, so it's less than 0.05. Therefore, this regression is significant. However, we look at it and for each of the variable or the independent variable. Let's look at the attitude. As you can see, it is 0.00. It means that this is a predictor. So attitude is a predictor. However, we might want to reconsider our model because of this result, 0.14. Again, the default is 0.05. It should be lesser than 0.05. However, this is high, 0.14. So therefore, educational attainment is not a predictor for the income. No, so this is like a very good one in a social science. So as you can see, that's how you look at this one. And when you report, I think you, when this is the result that most of the independent, actually we have two independent variables. So we look at the attitude and educational attainment, and this is just a make data. It's just I created this data. So sometimes this might be true that the educational attainment is not, could be not a predictor for your income. No, that's how it works. However, the attitude would be a predictor. So you might want to consider not using multiple regression. However, so to look at it, if it is combined, the educational attainment is not a predictor. However, the attitude would be a predictor. Okay. I hope you learned something with this video about multiple regression, and you would use this one to see prediction. You can use you can use two or more variables as an independent to look at which one is predictor or not. So I hope you learned something, and thank you very much for watching. Have a great day.